So our last part of Unit 5 today has to do with focusing on one specific type of reaction. So last time we looked at sort of just all the different types. So we had our double replacement reactions and our oxidation reduction reactions. Those were kind of the two main categories that we can identify. But then within those, there are some sort of more specific types. And so if something is oxidation reduction, it can either be synthesis, decomposition, single replacement, or combustion. And so we looked at all the different patterns for what those types would look like, so that you can recognize them and be able to identify and then categorize them correctly. And then for double replacement, we have two possibilities there. We have acid base, which is also called neutralization. So those two terms are kind of used interchangeably. And then the other one was called precipitation. And so we looked at examples for what they would look like, because all of these different types of reactions, they have some sort of pattern. And so if you know the pattern, then when you look at a chemical reaction that you're given, you should be able to categorize it into one of those categories, one of those like 6 specific ones. And then if you know which specific one it is, then you should also be able to tell me, is it oxidation reduction or is it double replacement? Okay. So today I told you guys we were going to look at specifically single replacement reactions, because we are going to learn how to predict. If they only give us the reactants for a single replacement reaction, I can predict what products I'm going to make. Okay. And so that's what we're going to look at today. So you have sort of a notes in here. We're going to look at this quickly, and then we're going to do some practice together before you guys have your practice for your assignment. So single replacement reactions, a lot of times, as you'll see kind of from the little meme, the little image that's on this little cover for the assignment or from the notes today, a lot of times people like to think of it as like, oh, there's a couple, and then here comes this other, other guy or other girl, and they steal the other person's partner. Okay, because that's kind of what it's like. You have a compound. Okay, so you have a compound where you have, a positive and negative ion. They've bonded together to make that compound, but another single element comes in, and if it is able to, and we're going to talk about how we know if it's able to today. If it's able to, it's going to kick out one of the elements in the compound, and it's going to take its place and form a different compound. And so that's why it's single replacement, because there's a single element that's trying to replace one in the compound. And so you can kind of think of it like that drama where there's a couple, and then somebody comes in and they steal the girl or they steal the guy, and then the other person's left single and they're all sad at the end. Okay. And so the background on here, this shows you an example of, this is like a silver cup that has done what's called tarnishing. And so tarnish is an example of a single replacement reaction that you might observe. Another one is like rust. Rust is a single replacement reaction because rust is formed when iron reacts with water. Okay. And so all these things that we see maybe in everyday life, these are actually types of reactions, and a lot of them are a lot of times they're single replacement reactions. All right, so okay, so how do we figure out if a replacement reaction will take place? We use this thing called the activity series, and that's what we're going to focus on today. And so when you go to the next page, so these are kind of small versions. When you get to the next couple pages, you're going to see these a little larger. But there's an activity series for metals, because metals can only replace metals. And then there's one for our non-metals. Now, sometimes they look different depending on where you look them up on the internet or in a textbook. Sometimes the non-metals, they leave off oxygen and sulfur and phosphorus. They only do the non-metals that are in group 17, the halogens. And then on the metal list, a lot of times they include hydrogen, even though hydrogen is technically a non-metal. And the reason they include it is because if you have an acid or you have water, a metal can replace the hydrogen in the acid or in water. And the reason is that if you remember, hydrogen has a positive charge like metals because it's in group 1. And so because it has a positive charge, it's on that list of metals instead of the list of non-metals. And so what this is saying, it says in general, a metal, it can displace or replace any of the metals which are lower in the activity series. Okay. So if we look at this example, number one, I should be able to tell this is single replacement just from looking at the reactants, because I have a single element and I have a compound. Okay, that's the only type of reaction that's going to have that pattern. If we have, you know, two elements, that might indicate that it's synthesis and they're going to make one compound. All my other reactions typically have two compounds on the reactant side. Both of the double replacement, the precipitation and acid base, they have two compounds. Combustion doesn't have two compounds, but it always has that specific carbon hydrogen compound and oxygen. Okay, so it's got that very specific pattern. For decomposition, I'll only have one substance on the reactant side, not two. So I should, number one, be able to kind of figure out, oh, this is single replacement. That means I need to look at an activity series to figure out what my products are going to be. And so in this case, the single element is this magnesium, which is a metal. And that means it would replace the metal in the compound. And in this compound, the metal is copper, Cu. So what I would do is I would come to my activity series of metals and I would find magnesium. Here's magnesium up here. I would find copper. It's in green down here. And magnesium is above copper. So that means it can replace it. So it's going to kick the copper out. So notice now here on the product side, copper is the single element by itself. And now magnesium is paired up with the nitrate in the compound, okay, because it's more reactive. The thing you have to watch out for when you write the formula for this compound, you have to be careful of your subscripts. Okay, in this one, it just so happened that both the copper and the magnesium in the compound, they both have a +2 charge. So the nitrate needed parentheses and a 2 out here, but that won't always be the case, okay? Sometimes the thing you're pairing it up with has a different positive charge than this metal. So when you write the formula for the compound on the product side, you have to check your charges. Don't just assume that it's going to have the same subscripts as it did on the reactant side. And when we do practice together in a few minutes, we're going to look at examples of what I'm talking about when I say that. Here's another example, okay? Again, I should be able to tell it's single replacement because there is a single element and a compound, and it's not that combustion pattern where it's, you know, hydrogen, carbon formula and oxygen. So here my single element is the metal gold, Au, and in my compound, this is an acid. So there's not a metal. So if you have an acid or you have water, the metal's going to try to replace the hydrogen. Okay, and so because that's the positively charged ion in this compound. And so what I would do is I would find gold. Gold's all the way here at the bottom. Gold is the least reactive metal. That's why if you notice the things at the bottom, there's like gold and platinum and then silver and palladium. All the stuff towards the bottom, it's not reactive. That's why we use it to make things like jewelry and building materials. You know, we use gold, platinum, and silver to make jewelry. We wear it. It touches our skin. If it was reactive, we wouldn't want to do that because it would be reacting and it would cause, you know, maybe color to stay on our skin. It could burn us. It just depends on what it does. So if you've ever seen somebody that, like, you know, they're wearing a ring and they take the ring off and there's like a ring where it looks kind of like greenish on where the ring was on their skin, what that means is that the ring was not probably pure gold. It means it had one of these other metals mixed into it, and that metal is reacting with the things in the air, probably like oxygen and sulfur gases, and that's leaving that residue. It's causing that residue to be left on your skin. And so that's how you know, like, if jewelry's like cheap, because they'll mix the gold or the silver or the platinum, they'll mix it with some other metals that are cheaper. But you can tell because it leaves that residue because it's actually reacting with things in the air and it's leaving it on your skin. Okay. But things like gold, they're not reactive. So it's the bottom and hydrogen is up here. So gold cannot replace it. And so instead of actually writing formulas for products, we just simply write no reaction, or you can write like capital N, capital R, just to abbreviate no reaction. Okay. The nonmetals, the concept is the same. They work the same way. If it's higher, it's going to replace it. If it's lower, it will not, and it'll be no reaction. And so for this one, the single element is fluorine. Now notice that it's F2. That's because a lot of these elements on here are diatomic. Fluorine, chlorine, oxygen, bromine, iodine, all 5 of those are diatomic. So you have to be careful because you have to remember that this is always, when it's by itself, it's not in the compound, it's always like F2. Or if you have oxygen, it's always O2. Or if you have hydrogen, it's always H2. Okay. So what happens is since this is a nonmetal, fluorine, it's going to replace the nonmetal in the compound, which in this case would be the bromine. Sodium is a metal, so fluorine cannot replace sodium. So it's going to replace the bromine, and because if we check the chart, fluorine is the most reactive nonmetal, so it's all the way at the top. It'll replace any of them. Bromine's down here, it's kind of in the middle. So it will replace it. And so what happens is bromine gets kicked out. Bromine is now by itself as an element, but notice it's Br2. I did not just write Br. Okay, that's because it is a diatomic element. So when you write diatomic element formulas, they have to have that 2 subscript. Okay. And then for sodium and fluorine, notice it's just NaF. Some of you guys might be going, well, where did the 2 on the fluorine go? Well, it's not needed because this is an ionic compound and sodium is in group 1, so it has a +1 charge. Fluorine is in group 17, it has a -1 charge. Those cancel out, so I don't need subscripts for this formula. It's just NaF, okay? It is unbalanced right now, so I would need to balance it. I would need to put a 2 coefficient here in front of NaBr, and I would need to put a 2 coefficient in front of NaF in order to have both sides be balanced, okay? So this equation is just writing out the formulas. We haven't balanced anything, okay? So there's a video down here that I would encourage you to watch later on if you have not already. And then here is practice that you guys are going to do. So here's the activity series of metals, and so it's kind of long. You can scroll. We also included hydrogen on it, okay, because that acts like a metal. Most activity series are going to look like this. They're going to start with the most reactive at the top, the least reactive at the bottom. Usually they don't go the other way, but they could also be horizontal, because like when you look at your assignment today, the one on your assignment, it's actually horizontal. So on this one, you are dragging and dropping. So is it going to be no reaction, or is it going to make products based on the activity series? We're not worrying about them being balanced, okay? And then on the next one, you have some with the nonmetals. So kind of same concept in that you are, going to tell me, did they make products, or is there no reaction? Okay. When you're finished with practice and you go to the next page on Canvas, you will see that similar to this, you have some practice where you are going to use activity series to predict and answer some questions. And so there are 5 pages on here. So pages 1 through 4 are where there are activities that you need to complete and submit. When you get to page 5, make sure you click Submit Report. Okay. So it has, again, kind of a summary up here of single replacement and what it would look like. And then there are, based on using your activity series, which if you go here to the second page, here's the activity series. So this is what I was talking about. This one's horizontal. So notice it has most reactive over here on the left and then least reactive on the right. So if you notice, like they're in the same order, like lithium's the most reactive, gold's the least reactive. It's just they're horizontal instead of vertical. So just make sure that when you're looking at an activity series, that you're reading where is the most and least reactive side, so that way you know how to use it. And so again, you have some kind of drag and drop options. Some of them are like yes and no answers. Some of them are the actual formulas. And so you will drag and drop the correct things to their correct spaces. And then you can hit check. And then you'll go on. So the next one has some predicting again. Is it going to be no reaction, or is it going to produce something? And if so, what'll it be? You'll do that one and then hit check on that one. The third page, this specifically is going to be ones that they're all going to be a metal reacting with water. So if you notice, they all have kind of the same pattern. It's a metal reacting with water. And so when that happens, remember we talked about the metal replaces the hydrogen. And so you will kind of figure out what the products and things should be on here, okay, and drag them where they need to go. This last one is they're all metals reacting with acids. So again, the metal is going to be replacing the hydrogen that's in the acid formula, and you will tell me what are the products going to be, okay? Once you do all 4 of those and you check them, Then when you get to the 5th page where it has the summary, it should tell you that, you've completed everything here. So just make sure that you hit submit report here so that it sends me your grade. Okay. What I'm going to do now, I'm going to switch over to the iPad that I have because we are going to do some practice together on using this activity series. Okay, so I have sort of a practice sheet here, and we're going to go through and do some together before you guys practice, because next time on Tuesday on your test, you are going to have probably at least a couple of questions where you're going to have to do this process. You're only going to be given the reactants, and you have to use the activity series to determine, does the reaction happen, or if it's no reaction. And then if the reaction does happen, you're going to have to figure out how to write the formulas for the products. Okay. And so this has kind of got step by step of sort of a process to help you. Number one, you want to identify the elements, and you want to look at the ions that make up what ions are going to make up this compound that you're going to write on the product side. Because remember, I told you, you have to know their charges, okay, so that you can correctly write that compound formula. So then you need to use your periodic table and your reference chart and identify those two ions and what are their charges, because based on the group that they're in, or if it's a polyatomic ion, you may have to look at your reference chart for the list of polyatomic ions. Based on what they are, you should be able to look up their charges from your periodic table and your reference chart. And then you'll use those two ions and their charges to create the new compound. So it says here again, remember to cancel the charges and write that as your first product. And then your second product is going to be B, which is just the single element. It just says, remember, you got to check out diatomic elements. Like, for example, hydrogen always has to be H2, not just H. And those other diatomics like fluorine, chlorine, bromine, iodine, oxygen, and nitrogen. Okay. So I'm going to come down here and we're going to do some examples together. Let me scroll back up so you can see the process. So number one, okay, I have Ba, that's my element, and I have this compound. So first thing I need to figure out is Ba, is that a metal or is that a non-metal? Because that's going to tell me which activity series list to look at. If that single element's a metal, I need to look at the long list that has all the metals. If the single element is a non-metal, then I'm just going to look at that short list that only has the non-metals. So what do we think on this one? Ba, barium, is this a metal or non-metal?
A metal.
It is a metal, and I'll switch over so you guys can see the reference chart, but with the periodic table. But so if I look at my periodic table, and this is the reference chart that you guys have on Canvas to use for your tests, barium is over here. It's in group 2. It is a metal. Okay. So that means I need to look at the metal activity series. And what's the metal in the compound? Let me go back. So in the second thing, so we know barium's a metal. So now which one of these is a metal in here, Al or Cl?
Al.
Yes, so Al, because remember a couple things. Number one, the metal will always come first in the name or the formula. But number two, if I'm not sure, if I can't remember that, Al is right here. Cl's over here. Okay, Cl's on the right of the stair-step line. That's a non-metal. So aluminum's a metal. It's on the left of that bold stair-step line. So that means that barium, since it is the single element over here, barium is going to try to replace aluminum because that's the metal in the compound. So what I need to do is I need to look at my activity series and I need to ask myself, is barium above aluminum on the activity series? Because if it's above it, that means it's more reactive and it will replace it. So on your reference chart, if you are using this to help you on the second page, so the periodic table is the most of what's on the first page. If I go to the second page, right here, here are my activity series. Okay. They're not exactly like the one in the notes. For example, the nonmetals, like I told you, it only includes the halogens, the ones that are in group 17. It doesn't include oxygen and sulfur and phosphorus because a lot of times they are not always participating. They're not as common, I guess, in these reactions. So a lot of times they get left off of the list because the halogens are the ones that mostly are the ones doing reacting. Okay. But you notice it says decreasing activity, and then it even has a little reminder, elements cannot replace anything above them. The reaction does not occur. And then it says hydrogen's a nonmetal, but it acts like a metal in chemical reactions because it's positively charged. Okay. So where is barium and where is aluminum? Here's aluminum and here's barium. So is barium above aluminum? What do we think?
Yes.
Yes, it is. So that means barium will replace aluminum. So that means on the product side, barium is going to be in a compound with chlorine, with the Cl. Now, that means Ba and Cl, those are going to be our ions. So I need to come back up here to my periodic table, and I need to look, okay, barium is in group 2, and everything in group 2, that has a +2 charge. Chlorine over here, chlorine's in group 17. Everything in group 17 has a -1 charge. Okay, I need those numbers because I need those in order to correctly write the compound formula when barium and chlorine bond. Okay, so I'm going to go back to our practice sheet. Okay, so I know, and I'm going to write this off to the side, but I know that barium is +2, and I know chlorine is -1. Okay, those are the ions that are going to make the compound that I'm going to write here for my first product. So now I need to, crisscross their charges or balance them out. So if I crisscross the 2 down here and the 1 here, I end up with Ba, and then I don't write 1s, okay, so I don't write anything after barium, but after Cl, I do have to write the 2 subscript because I crossed that down. So that's the correct formula for the compound that's produced, because barium will replace aluminum and bond with chlorine. And because of the charges on barium and chlorine, the formula for that compound is BaCl2. So this is an example of what I'm talking about. A lot of you guys would have written BaCl3 because you would have just copied that subscript straight from the first thing on the reactant side. You cannot do that. Okay. Sometimes, will it be the same? Sometimes, but not all the time. So you cannot assume that it's going to be the same. Okay. You have to check the charges for the ones that you're putting together to create the new compound. That's what step 3 is telling us. Okay. So then step 4, the last thing, is the other element, which in this one is the aluminum. It's written as a single element. So now it's just Al by itself. Okay. It's all sad. It's now single and lonely. And aluminum is a metal, and our diatomic elements are all nonmetals. So I don't need to worry about giving it a 2 subscript. Okay. So that's it. I'm done predicting. Now, if I want to worry about balancing, because right now this is not balanced. The chlorines are not balanced because there are 3 here and 2 here. So I might be asked to balance it, in which case this is a situation where, I have 3 on one side and 2 on another, and 2 and 3 don't have anything in common because 3 is an odd number. But what I can do is make them both 6. And so in order to do that, I'd put a 2 here because that 2 would multiply by the 3 on that chlorine and make 6. And I would put a 3 here because that 3 would multiply by the 2 subscript for the chlorine on the product side and make it 6. So now both of the chlorines are 6. But now if you notice, this 2 over here also multiplied by the aluminum. So I need to put a 2 here. And then this 3 multiplies by the barium. So I need to put a 3 here. So I end up having to put coefficients on everything here, 3, 2, 3, 2, in order to make it balance. Okay. If you're not asked to balance, if you're just predicting, then you only have to write like what I have in red, which are the formulas for the products. But if you also have to worry about balancing, then at the end, you may have to add in some coefficients just to make sure all your amounts are the same. Okay. All right. So let's take a look at number 2 on here. So on number 2, I'm going to change colors really quick. On number 2, here's our single element. Okay. It's by itself. is that single element a metal or a non-metal? Based on, so it's F. So if I go back to my periodic table, yeah, F is a non-metal. It's over here. It's fluorine. Okay, it's in group 17 over here. And so it is a non-metal, and that means it's going to try to replace the non-metal that's in the compound. And the non-metal in the compound is always going to be what's second. So the non-metal here is the Cl. So F is trying to replace Cl. So I'm going to need to look at my activity series for the non-metals. So I'm going to scroll down here to the second page. Okay. So we're not doing that one anymore. Okay. So here, my non-metal list is pretty short. And actually, if you remember, there's a trick, because if you look the order that they're in, the FClBri, they're in the same order that they are up here on the table, FClBri. They're all in the same group and they're in the same order. So for the non-metals, you really don't even need to look at the list. Just look at what order they're in on the periodic table, because fluorine's the most reactive, iodine's the least reactive, and they go down in order. Okay. But whether you look at the periodic table or you look at this list, I can see fluorine is above chlorine. It's right above it. Okay. So that means this reaction will happen, and fluorine will kick out the chlorine. So that means that fluorine, which is a non-metal, so I'm going to write it second, fluorine is going to make a compound with sodium. So I need their charges from the periodic table in order to write the formula for it correctly. So I need to look at what groups they're in. If I come back over here, sodium's here in group 1. Everything in group 1 is +1. Okay, so sodium, because it's in group 1, it's a +1 charge. Chlorine, it's over here in the same group as fluorine was on our earlier, or everything in here is -1. Okay, so I have a +1 and a -1 on this one. So +1, -1. So if they're the same, they're both ones, they cancel out. I don't really need to crisscross anything. That means there's no subscripts needed. So that means this is just NaF. Now, for the chlorine getting kicked out by itself, okay, that last thing is to write it. But remember, I need to check for diatomic elements, okay, because chlorine's a non-metal, and remember, most of our, or all of our diatomic elements are non-metals. If I come down here on my reference chart, the diatomic elements are listed right here. Okay, it has their names, not their formulas, but you know, you should be able to look them up. And chlorine is on this list. It's right here. It's the next to last one. And so that means it's not just Cl. That means that I got to go back here and I have to make it Cl2. And then those would be the correct products. And then again, this one is not balanced because it's not balanced because we have diatomic elements here. And so, but this one's a little easier to balance because, for example, there's 2 chlorines here. So I can put a 2 in front of here, and that makes there be 2 chlorines here. There's 2 fluorines here, so I can put a 2 in front of here, and that gives me 2 fluorines. And then both of those 2's also multiply by the sodiums, and so that makes the sodiums balanced as well. Okay. All right, let's look at the next one. All right, so single element Mg, is this a metal or a non-metal?
Metal.
It's a metal, and what's it going to replace here in the compound?
Nothing. H.
Yeah, so this one's a little tricky. That's why I put this one on here next. So it's going to replace hydrogen, because remember, we talked about hydrogens. Technically, it's not a metal, but in reactions, most of the time it acts like a metal because it's going to be positively charged. So in this case, even though there's not a metal in the formula, that formula is an acid. It's hydrofluoric acid. If there's a metal, it'll always try to replace the hydrogen, either in an acid or in water. Okay. So Mg is going to try to replace H. So let's come look on our activity series and see, is Mg above H? Here is Mg. And then hydrogen, which notice they have it as H2 because they're reminding you that if it gets kicked out, it's going to be H2 because it's diatomic. So Mg, it definitely is above H. It's way above H. Okay. So that means that it is going to get kicked out. Oops, let me click on that. So Mg is going to kick out H. So that means that, I'm going to change colors again. That means that Mg is going to pair up in a compound with F, okay, because it's going to kick that hydrogen out. So I need to know charges. Well, we just did fluorine on the last one. It's -1, okay, so I don't really need to look that one up again. But Mg, I need to know the charge for Mg. So if I go back to my periodic table and I look at what group is magnesium in, here it is right here. If I go up, it's in group 2, which is a +2 charge, just like the barium from our first example. They're in the same group. So that means this is a +2. So that means I would have to kind of crisscross them. And so I end up with Mg, and then there's an imaginary 1 after the Mg because I don't write ones, and then F2. So that's the correct formula. And then my other product is going to be the element, which will be hydrogen, but hydrogen's diatomic, so it has to be H2. Okay, so those are the correct formulas for the products. Now, again, this one is not balanced. If you look, there are 2 fluorines and 2 hydrogens on the product side because of the subscripts that we had to write for the formulas. And so to fix it, I just need to add a 2 coefficient in front of the acid here, and that multiplies by the F and the H, and that fixes everything. So only 1 coefficient's needed on that one. All right, next one. All right, so the single element is here. Is this a metal or a non-metal? Br. Let's see, we'll go look at the periodic table. All right, Br is right here. It's in group 17. That would make it a non-metal. Okay. That means it's going to try to replace the non-metal that's in the compound. And in the compound, the non-metal is the second one, so that's going to be Cl. So I need to look at this activity series. Is Br above Cl? So if I come down here to my non-metal list, that's the short one. Here is Br. It's the third one, but it is not above Cl. Br is below Cl. Cl is higher. So since Br, the single element, is not above chlorine, that means it cannot replace it. And so there are no products, there's no formulas to write. All I would write is, I would write no reaction, or you can just write NR to kind of shorten it. So you don't have to write any formulas, you don't have to worry about, balancing or anything, you just write no reaction or NR, and that's it, you're done on that one. Okay. So that's how it would work if you get one that's a no reaction. The single element's lower than the one it's trying to replace in the compound. That means it can't do it and it's no reaction. All right. Next one. Okay, so we have Ag. Is that a metal or a non-metal? Back to our periodic table.
Metal.
It's a metal. Ag is silver. It's a transition metal right here in the center. So Ag is a metal, so that means we're gonna have to look at our activity series for metals. And so then we got to figure out the metal in the compound. It's the first element, so it's going to be Mg in this case. So on my activity series, I need to see, is Ag, silver, above Mg, magnesium? So if we go down here, all right, so here, let's see, Ag is, oh wow, Ag is all the way down here. So it's probably not going to replace it because the only thing silver can replace is platinum and gold, okay? Mg is all the way up here. And so Ag is not above silver. Ag is not above magnesium. Therefore, it cannot replace it. And so this is going to be another no reaction. And that's it. So that is the basic process. When you guys do your practice on Canvas, you're literally doing this exact same thing. The only thing is it's slightly easier because I made it fill in the blank and I gave you options. So on the practice on Canvas, you're not totally having to do this part over here as much, the part where we had to look up the charges to write the formula correctly for the compound. So the reason that I wanted to go through these together in class is because there are going to be some on the test where you're going to have to do that. So what I would recommend that you do when you are doing the practice on Canvas, and I'm going to switch over to show you the screen just so y'all can see it. Y'all can see what I'm talking about when I say this. All right, so let's say I'm on here doing these practice ones, okay? Doesn't really matter, any of the sections, they're gonna be pretty much the same. We'll go to the second one. So let's say I'm on here and it says, you know, drag the products or words into the correct boxes, okay? So this first one, I have AU plus AgNO3, okay? So my mind should go, okay, AU, is that a metal or a non-metal? AU is gold. That is a metal. So it's going to try to replace the metal in the compound, which is Ag, silver. I would look at my activity series. So up here, it's this horizontal one. Au, gold is the least reactive. So it's lower than silver. Silver is a little bit higher. So this one I would drag a no reaction to. Okay. Now, let's look at the next one. The next one, they give us the compound first, which they can do that. Like it does not always going to list the element first. As long as there's an element and a compound on the reactant side, it's single replacement. Doesn't matter which one's first. Okay. This one, the single element's written second. It's nickel, Ni. Okay, so nickel is, oh, they didn't give you nickel on this one. You'll have to use the one. Oh, wait, no, here it is. I thought it wasn't there for a second. Nickel is right here, Ni. The metal in the compound, again, it's silver, it's Ag. So it's down here. So in this case, nickel is more reactive than silver. So it will replace it. So when you look down here, there are going to be options. It's going to be kind of obvious which one it is, okay? Because not all the problems have nickel and silver and sulfate. But if you want to make sure you're practicing so that you can do the best on your test, what I would do is before you go down and look at the options that are in the boxes, try to write out, if I put nickel Ni with SO4 with sulfate, look up their charges and try to do it yourself, okay? Some of them are a little harder because like nickel is a transition metal, so it could be like a 2 or a 3. So, you know, practice writing it with both if it's 2 or 3, and then when you look down here, you'll see there's only like one possibility. So that's what I would recommend is when you're going through these, try to write the compound formula on the product side first before you look at your choices. Because if all you do is look at the choices and you're like, oh, okay, it's obviously this one, then some of your questions on your test are going to be a little difficult if that's what you're doing. Okay. All right. Any questions on what we have gone over today or like what you're doing for your assignments? Oh, I see something.